problem with this problem that is that we have cosine and sine in there. It sort of would be example number 4, except that the last problem was actually just kind of a one I wanted you to try. That's on your homework. Shh. Try it on your homework without looking at your notes, okay? See if you can remember how to do it. And then this one is just the example 3 on the papers I'm looking at. So
how did you email it?
no, let's do this first. Okay, what should we do? What's the problem here? We have a cosine and a sine in there. Is there some sort of identity, Jordan, that we can use to get rid of that cosine squared? So cosine squared can be rewritten as 1 minus sine squared, correct? Okay, but then we'll have a negative squared term, which I don't like having a negative squared term in a quadratic. So how can we make that term positive instead? Yeah, you know what I was thinking though is let's just move all this stuff over there.
But isn't that just positive? Like this, what do you think? Negative sine squared, then it's going to be a positive sign, right?
We're not squaring it. We're just... It's in parentheses because I replaced that with this. So I put it in parentheses so you could see what got replaced. But it's not going to go negative because this is just 1 minus sine squared minus 0.2 sine equals 0.9. Okay, so we need to now combine like terms, don't we, and get this positive. So I'm just going to plan on adding everything over here. So let's do add the sine squared to the other side, which makes it a positive sine squared. Add the 0.2 sine, which turns it into a positive 0.2. I put the point in the wrong place. Sine. This is a positive 1, so should I subtract the 1?
Yes.
So I have 0.9 minus 1. 0.9 minus 1. What will it be? Negative 0.1. And now since I moved all that stuff over, there's nothing left. So that means that that would be equal to 0, right? Does anyone want to factor this problem with decimals in it?
No.
So do you realize we can still just use quadratic formula for something like this? Do you know that you have apps on your calculator that you can plug numbers in and it'll do the quadratic formula for you? Probably, if you've downloaded the right ones. I don't remember which one would do that. Let me do some experimenting. And while I'm looking for an app that will do that for us, why don't you guys try doing this by hand? So what's the A value in this problem? 1. What's B? What's C? Negative 0.1. And remember, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So go ahead and try plugging that in and getting that answer for me. I think free graph calc might have something that'll do it. If you have free graph calc, I think that's the one I told you guys to download a while ago. If you go to free graph calc and you go to more, oh, there's a triangle solver. That will be, oh, polynomial solvers. Okay. I realize some of you are working on this, but here we go. Let's look at this together. So this is my free graph calc app, if you guys have that one. And then you've got your calculator, you've got your equations you can put in, you can graph stuff. You have a place where you can get to different formulas to look them up. If you've forgotten some of your formulas, you can look them up here, like quadratic formula, there it is if you forget it. Okay, but here's what we're going to use is more. If you go to more, you've got a triangle solver, which is going to be really, really handy in chapter 5 to check our work. And you've got polynomial solvers. So if we go to polynomial solver, we have a quadratic equation solver. So we can just type in A and B and C. And hit solve. And we should get two answers. X equals 0.231662 or negative 0.431662. Those are probably rounded, but that's okay. So I don't know if any of you were still doing that problem by hand, but we've practiced quadratic formula before. The only thing is you're not going to be able to use your iPods on the final. You can use a calculator, but you can also program calculators to do this. Do you guys want me to find out a program for quadratic formula and we'll program our calculators to do this? That would be cool, huh? Okay, maybe next time when we have a review day, maybe we'll do that. Okay, so going back to our problem, you still can plug these in and do this by hand and you should get the same answers. But I don't want to take the time for that right now. So this means that we just solved sine alpha. So sine alpha, it's not x that equals these, it's actually sine alpha that equals these. Okay, so sine alpha equals this, and sine alpha equals that. Two different possibilities. So how do we use our calculator then to find the angle that the alpha would be if for it to be this number? What do we do? Okay, inverse sine of 0.231662. And what did I say I wanted your angle in what range of numbers? 0 to 360, so in degrees. So that means we want our calculator in degree mode this time. All right, so everyone punch that in for me. Tell me what you get. Okay, we have a 13.4 degrees for quadrant 1. But we have another possibility. So, oh wait, and don't we even have another possibility for this one? So this would be quadrant 1, but where else is sine positive? Quadrant 2. So in order to get the quadrant 2 answer, this is like the reference angle. Yeah, perfect. So the calculator won't do this part for you. You actually have to realize that you're going to go 180 minus that 13.4 to find the quadrant 2 answer. Good, very good. 166.6. Okay, so that's the positive one, but now we need to do the inverse sine of the negative answer. Okay, calculators. Okay, but can we list that as one of our answers? No, because that is a negative angle and we want our angles to be between 0 and 360. So you use this as the reference angle, but what quadrants will it be negative in? Quadrant 3 and quadrant 4. This one already is quadrant 4, but we want a positive angle in quadrant 4. So how do we get the coterminal angle with that angle in quadrant 4? Add 360. Good. So what's negative 25.6 plus 360? It's going to be less than 360. 334.4 degrees. Good. So that one is quadrant 4. But then there should be another negative answer in quadrant 3. So if this is the reference angle and it's quadrant 3, how do you find the angle in quadrant 3 if you have the reference angle? Good. So we take 180 plus that reference angle, 25.6. so that it will be between 180 and 270. And we add that in, and what do we get? (205.6 degrees). So this one has 4 solutions. 2 positive solutions in quadrant 1 and 2. 2 negative solutions in quadrant 3 and 4. Well, the solutions themselves aren't negative, but they're based on a negative ratio. Because it was a quadratic, so there was a positive ratio and a negative ratio, and then each of those ratios led to 2 answers, right? So the positive ratio led to answers in quadrant 1 and quadrant 2. The negative ratio led to answers in quadrant 3 and quadrant 4. So there are 4 total answers. Cute! Awesome!